here is pre-calc. It's a little mini lecture on lesson 1.2.1, and it's all about composition of functions. And so you might have already learned about this in previous courses, but basically when you compose a function is when you take the output of one function and use it as the input of the next function. So you're kind of plugging the output of one function into another function. So this one, it starts out with just kind of like these two tables of these two different functions. And let me push autofocus so that it will be a little nicer. I don't know if that helps. So, for instance, like letter A, if I wanted the kindness score when the wisdom was 4, well, see how this one has input of wisdom and output of kindness? I can just go to the 4 and I can say the kindness score is 4.8. But you'll notice this one, you're inputting a kindness score and you're getting out a generosity score. So sometimes, like if you look at letter C, it says what's the generosity when the wisdom is 5. So I go to wisdom, which is 5, but they're asking me for generosity, but when I look up wisdom, I get 9.6. But it's okay because I'm going to take that 9.6 and I'm going to plug it into this other function so I can get my generosity. So when the wisdom is 5, the kindness is 9.6. So I go over here to kindness and find 9.6. Oh, there it is. And then I plug that in, and that gives me a generosity of 12.456. So it's like I'm using both tables. If I want to know what's the generosity when the wisdom's 5, I have to like do a two-step method. Like first I calculate the kindness score from this function, and then I take what I get, my output, and I plug it into the generosity function. So it's just this is just a little example. Basically, we're going to read together 1-6.4. It feels like you can't see it very well. Let me see if I can fix it. Maybe that's better. So it says composing functions means that the output of one function becomes the input for another function. In the previous problems, you composed functions that were represented as tables, and we skipped to the one that had a graph, but it's all done the same way. Functions represented as equations can also be composed. This can be thought of as stacking function machines, as shown in the diagram at right. The top function's output becomes the bottom function's input. The composition in this diagram is expressed as g of f of x and can also be written as g of f of x, or g composed with f of x. Use the diagram to complete the parts below. So it says suppose 1 is dropped into the f machine. Where's the f machine? Well, this one's f of x, that one's g of x. Okay, so 1 gets dropped into this top machine. What's the value of g of f of 1? Well, to get to the g, we got to go down here. So we're gonna plug in a 1 up here, and we'd have 4 times 1 plus 7. So that would be 4 plus 7. So that would give me an 11. And then in order to get the g, I have to plug it into the g machine. So I take my 11 from here, plug it in here, I got to square it and subtract 3. So 11 squared would be 121. And then I think if I subtract 3, 21, 20, 19, 118 is what I'm going to get out. So that would be the final output. So then if they want g of f of negative 0.5, I plug in negative 0.5 in for x, like negative 0.5 times 4 plus 7. And then since they want the g output, then whatever number I get, I plug it in here, like square it and subtract 3, and that's how we answer these. So when it says g of f of x, let me show you what they want us to do. So g of f of x, it means plug f of x into g of x. So the way I usually do it is I'll write g of x, but with some like parentheses. See how g of x is x squared minus 3? So I'm going to write something squared minus 3. And then I'm going to plug f of x in right there. I know f of x is 4x plus 7. And then, I mean, that's okay. I could actually clean that up a little bit. I could square this thing out if I wanted to. I could say 4 times 4, that's 16x squared. Let's see, 4 times 7 is 28. 28 times 2. What's 28 times 2? 56. That's just if I wanted to clean it up. I don't know, maybe it's fine just like this. 49, 47, 46. That's just another way. This is just another way to write this. But the point is, I probably shouldn't have done all that. The point is that if it says g of f of x, you take the f of x and you plug it in everywhere where there's an x in the g function. I don't think that's a super crazy thing for you to think about, because I think you've been doing a little bit of that kind of stuff in your homework. So, and then if I wanted to write an equation for g of f of x plus 1, I'd have to plug x plus 1 into the f function, and then take whatever I get out of that and plug that into the g function. And then it says, does the order that the function machines are stacked matter? That is, in general, does f of g of x equal g of f of x? Explain and provide examples and counterexamples. So do I have enough time to do that? How many minutes are we? We're at 7 minutes. Let's try to do that really fast. So f of g of x, and then g f. I know you can't see it yet. I'll have to move some things around so you'll be able to see. Okay, so f of g of x, if I want f of g of x, that means I have to plug g of x into f of x. So I'm going to write f of x, which is 4 times x plus 7, and I have to plug g of x in there. So g of x is x squared minus 3. And they're saying, is that the same as g of f of x? So let's see what I get when I might have to clean that up a little bit. G of f of x. So that means I have to plug f of x into the g function. Well, the g function has x squared minus 3. I'm going to plug f of x in there. Didn't I already do that? I mean, they look a little different from each other. This one I've already done because I did it right here. Remember when I plugged it in? It was 16x squared plus 56x plus 46. What does this end up being? Is that -5? These aren't the same, are they? That and that, I can tell they're not the same. So if they say does the order matter, I'm going to say yes. And that's my example. I think that's enough for you guys to be able to do your lesson.